Welcome to Inem Technologies on YouTube. As you know, we've been focusing on a series of instructional videos covering Java and Selenium automation. Now, we are excited to announce that we are expanding our content to include a comprehensive series on Playwright automation. We'll start from the basics and cover a wide range of topics to make you proficient in Playwright automation. To stay updated with our latest content, please consider subscribing to our channel and hit the bell icon. This way, you'll be instantly notified whenever we upload a new video. Your support is invaluable to us. What is Playwright? Playwright is an innovative automation framework introduced by Microsoft in 2020. Designed for end-to-end testing of web applications, Playwright supports a range of browsers, including Chromium, Firefox, and WebKit. So, what sets Playwright apart? First, it offers a high-level API that simplifies the control of browser instances. It also comes equipped with built-in functionalities to handle common but challenging scenarios such as browser dialog interactions, native input events, and even the capturing of screenshots or recordings. One of the tool's standout features is its capabilities for cross-browser testing. With minimal code changes, you can run identical tests across different browsers. Additionally, Playwright supports both parallel execution and headless browsing, making it a versatile choice for modern web application testing in 2023 and beyond. Stay tuned as we delve deeper into these features and more in our upcoming videos. Playwright was developed by Microsoft as an open-source initiative, building upon their earlier framework known as Puppeteer. While Puppeteer was primarily designed with Chrome in mind, Playwright took a step further. It aimed to extend these capabilities across a variety of browsers. This marked a significant evolution, giving birth to a versatile and cross-browser automation tool that we see today. One of the remarkable attributes of Playwright is its multi-language support. Introduced by Microsoft, Playwright extends its appeal to a diverse developer community by offering bindings for JavaScript, Python, and even .NET. This means whether you are a JavaScript aficionado, a Python enthusiast, or a .NET expert, Playwright has you covered. The importance of this language flexibility cannot be overstated. It allows development teams to leverage their existing skill sets, opting for a programming language they are most comfortable with. This ease of language choice not only streamlines the development process, but also makes Playwright a versatile tool for web automation. Another compelling factor behind Playwright's rising popularity is its active and thriving community. Being an open-source project backed by Microsoft has greatly contributed to fostering a community-driven ecosystem. This commitment to openness has encouraged developers worldwide to participate and collaborate. As a result, Playwright has seen a flourishing of plugins and extensions that augment its native capabilities. From additional selectors to customized reporting, the ever-growing repository of community contributions makes Playwright a continuously evolving and increasingly potent tool for web automation. Playwright is not merely a standalone automation tool, it's engineered for seamless integration with a variety of testing frameworks and CI/CD pipelines. This makes it an invaluable asset in DevOps environments. Its design allows for easy plug-and-play into existing workflows, streamlining the test automation process from development to deployment. Whether you are using Jenkins, GitHub Actions, or any other CI/CD solution, Playwright fits right in, ensuring a smooth and efficient automation experience. The versatility and rich feature set of Playwright have made it a popular choice among both enterprises and individual developers. Many industry professionals are recommending Playwright as a robust alternative to other established browser automation tools, such as Selenium. This widespread adoption serves as a strong testament to Playwright's effectiveness in web automation. Whether you're a startup or an established organization, Playwright's capabilities make it a reliable solution for your web testing needs. Let's pause to evaluate Selenium and Playwright, two major contenders in the field of web automation, by examining key characteristics outlined in this table. First, concerning programming language compatibility, Selenium provides bindings for a wide array of languages including Java, Python, .NET, JavaScript, Ruby, Perl, and PHP. Playwright, conversely, primarily targets JavaScript but also accommodates Python and .NET. In the realm of browser support, Selenium is compatible with Firefox, Chrome, Safari, and Edge. Playwright, however, concentrates on Chromium and Firefox and broadens its reach to other browsers via WebKit, ensuring a consistent cross-browser testing experience. A noteworthy point about community engagement, Selenium has recently experienced a decline in code contributions and hasn't introduced new features. In contrast, Playwright has been on an upward trajectory since its 2020 launch, fueled by Microsoft's active participation. Regarding inherent functionalities, Selenium often relies on external utilities for actions like screenshot capture or native event simulation. Playwright, on the other hand, comes preloaded with such features. In terms of CI/CD pipeline integration, Selenium is capable but may necessitate extra configurations. Playwright is engineered for seamless integration into contemporary DevOps practices. Finally, while Selenium enables parallel test execution through additional configurations like Selenium Grid or third-party libraries, Playwright natively supports parallelism in test execution. What makes Playwright the right choice? Rapid execution time. When compared to Selenium, Playwright is engineered for faster test execution. This is particularly advantageous in agile development cycles where quick feedback is essential. Unlike Selenium, which may require a separate WebDriver, Playwright runs headless by default, offering a speed advantage. Built-in wait mechanisms. Selenium often requires explicit waits or sleep functions to handle delays, which can lead to flakiness. Playwright, on the other hand, comes with built-in wait mechanisms that intelligently wait for elements, making your tests more robust and reliable. Reduced test instability. Test flakiness is a common issue in Selenium due to various factors like loading times and dynamic elements. Playwright addresses this by providing auto-wait features, thereby reducing test instability and increasing the reliability of your test suite. Integrated developer tools and video capture. While Selenium may require third-party tools or extensions for screenshots and video capture, Playwright offers these features out of the box. This makes it easier to debug tests and document their execution, providing a more integrated experience. Simplified coding experience. Writing tests in Selenium can become complex due to its extensive API and language bindings. Playwright offers a more simplified and intuitive API, making the coding experience more user-friendly and less cumbersome. Seamless API connectivity. Selenium primarily focuses on browser automation and may require additional libraries for API testing. Playwright allows for seamless API connectivity, enabling you to integrate API tests within your UI tests for a more comprehensive testing strategy. Now, let's move forward with configuring the Playwright automation tool in the Eclipse IDE. I will provide a step-by-step walkthrough for this setup. Should you require guidance on setting up Java JDK and Eclipse IDE, kindly refer to our earlier video on our YouTube channel, where we've detailed the installation process for Java and Eclipse. Now let's move ahead with establishing a new Maven project within Eclipse. Launch Eclipse and follow this path: File, New Project, then choose Maven Project. Make sure to select the option for Create a Simple Project by checking its checkbox, then click the Next button. Fill in the required information in the newly opened New Maven Project window. For the group ID, you may enter details pertaining to your organization, and then complete the artifact ID field. Initiate a new package within src main Java, and then go on to establish a new Java class. The subsequent action involves incorporating the necessary Playwright dependencies into your pom.xml file. Conduct a Google search using the query Playwright Maven dependency and opt for the Playwright main library dependency displayed. Copy the most recent version of the Playwright main library dependency and insert it within the dependencies tag of the pom.xml. Press the Save button to trigger the automatic download of the Playwright Maven dependencies. Upon successful completion of the download, the Maven dependencies for Playwright will be visible as shown here. Next, let's incorporate the essential TestNG framework dependency, allowing us to employ TestNG annotations for running our Java class, rather than using the main method. To make use of TestNG annotations for executing our Java class, let's include the requisite TestNG Maven dependency in our pom.xml. Conduct a Google search with the query testing Maven dependency and copy the most up-to-date version of the TestNG dependency. Remove the scope test element from the dependency, and this means that the TestNG dependency will be available not just during the test compilation and execution phases, but also during the compilation and runtime of your actual application. Press the Save button in your pom.xml to trigger the download of the TestNG dependency. Upon successful download, the TestNG dependency jar will be located under Maven dependencies. Next, let's move on to initiating the Chrome browser through the Playwright automation framework we've configured. Since we've installed the TestNG framework, utilize the @test annotation. If TestNG is not installed, you can opt for the Java main method as an alternative to the @test annotation. Before initializing the Playwright interface, ensure that your Java settings are correctly configured. Verify that your JRE system library is set to Java version 1.8 or higher, and that your Java compiler version is also pointing to Java version 1.8 or above. Let's now craft a new method titled Launch Browser. To generate the method's syntax swiftly in Eclipse, simply type the method name and hit Ctrl+space. Eclipse will suggest the method as private by default, but we'll adjust its access modifier to public. With the public keyword, our launch browser method stands ready, open to the entire application, inviting an array of classes to engage with the Playwright automation framework. Now, let's move forward with the initialization of our Playwright instance. To do this, we'll utilize the Playwright interface. Begin by entering playwright.create to instantiate a Playwright object. The playwright.create is a static method from the Playwright class that yields a fresh instance of Playwright. Once you've input playwright.create, use the Eclipse shortcut Ctrl+2L to quickly assign this new instance to a variable. Then, rename the variable from create to pw for clarity. Having set up the Playwright library in Java, we will employ the variable pw associated with the Playwright class instance. This variable pw serves as our gateway to the suite of methods offered by the Playwright library for browser automation. Next, we'll leverage pw to engage with the Chromium browser by invoking pw.chromium. Executing this function activates the Playwright API's Chromium-specific features, allowing us to interact and automate tasks within the Chromium browser. .launch, this method actually starts the browser. New launch options. This creates a new set of options for launching the browser. .setChannel, Chrome. This option specifies that you want to use the Chrome channel. While Playwright uses Chromium by default, setting the channel to Chrome tells it to use the Chrome browser specifically if you have it installed. If you replace .setChannel Chrome with .setChannel message, Playwright will then utilize your Microsoft Edge browser for automation tasks. .setHeadless, false. This sets the headless mode of the browser to false, which means the browser will launch with a GUI, graphical user interface. If set to true, the browser would run in the background without any visible interface. I'll go ahead and execute the code we've written up to this point. It seems there is a compatibility issue between my TestNG version and the Java version installed. Therefore, I'll proceed to specify a lower version of TestNG in the pom.xml file to resolve this. In my pom.xml, I initially opted for the latest version of the TestNG Maven dependency. I will now revert to the version just before the latest and attempt to rerun my code. Since this is the initial run after setting up Playwright, it's performing a one-time download of browsers like Chromium, Firefox, and WebKit. This is a standard process that only occurs once during the first execution. Having instantiated a web browser through the Playwright framework, we will now assign this object to a variable. This assignment can be efficiently accomplished using the Ctrl+2 and L keyboard shortcut. Now, we utilize the newPage method through the browser object that we've already initialized, representing the active browser session. Invoking newPage will generate a fresh page or tab within the browser, yielding a page object through which we can engage and manipulate the newly opened page tab. Let's proceed to assign the result of browser.newPage to a variable, which can be done quickly by using the keyboard shortcut Ctrl+2L. This action will create a new variable that references the new page or tab opened in the browser by the newPage method. We will now employ the navigate method from the Playwright page class to proceed to a specified web address. Let's execute our script now to verify if the Chrome browser launches and navigates to the URL we have designated. Excellent! It's great to see that Playwright successfully launched the Chrome browser and navigated to the Google search page as intended. Let's proceed to execute the same script, this time to open the Google search page with the Edge browser. The adjustment required in your script is simple: replace .setChannel Chrome with .setChannel message. Now, let's run the script again to confirm if the Edge browser is launched correctly. As anticipated, the Edge browser was launched and navigated to the Google search page. Perfect. As we conclude this video, I hope it has provided you with a comprehensive understanding of Playwright, its advantages over Selenium, and how to set up the Playwright framework to launch browsers for your automation needs. In our upcoming video, we'll delve further into Playwright's capabilities. Make sure to stay connected with our channel. Don't forget to click the subscribe button and hit the bell icon to receive instant notifications for our latest content. Thank you for watching, and we'll see you in the next lesson on Playwright.